So in this video we're going to be looking at different properties of logarithms. Some of these properties we've talked about or been hinted towards. The first two are those that are relatively easy. It's the last three that are going to be kind of tricky. Not that they're hard, they're just really easy to forget, to use those properties and get a wrong answer. And you'll see what I mean when we get to those problems. But for this first one, this is one we've talked a lot about recently, and that's called the log base b of b to the nth power theorem. Kind of a mouthful as far as the name of this theorem, but it's really a simple theorem. And it's this one. It's that if you have a log base b of b to the nth power, your answer is n. And we've talked about this one, where if this base and if this base are the same, your answer is going to be the exponent. So if we have log base 8 of 8 to the negative third power, your answer is just negative 3. If you have the natural log of e to the 2/3 power, remember from the previous video that a natural log means that we have a base e, a log base e. And since this base and this base are the same, your answer would be 2/3. So that's a log base b of b to the nth power theorem. So in other words, whenever your base for your logarithm and your base for the value that you're taking the logarithm of, whenever those two bases are the same, your answer is the exponent. The logarithm of one theorem is also an easy one to remember. It's just that the logarithm of 1 is always equal to 0. The reason for that is, remember, logarithms are equal to exponents. And so anything raised to the 0 power is always going to give you 1 as your answer. So for example, with this first one, log base 3 of 1. We know from the theorem it's going to be equal to 0, but the reason why is because 3 to the 0 power equals 1. Even if it's not log in log form, technically this is in log form, but you might say, well, it doesn't say log base b. It's a natural log, which means that we have a log base e of 1, but still that doesn't matter. Or the log of 1, doesn't matter what the base is, your answer is always going to be 0. It could be the log with the base pi of 1, and that's still going to equal 0. So these first two are the easy ones. Just remember that the log of 1 is always 0. And the other one is that anytime the bases for your logarithm and the base for the value are the same, your answer is the exponent. Now is where it gets a little trickier. This is called the logarithm of a product theorem. What this states is that if we have the log, this is the general form, just in general, log base b of x plus log base b of y, that equals a log base b of x times y. Now notice a couple of things here. Notice how the bases are the same here. Log base b of x and log base b of y is implying that you have the same base. So when you have the same base and you're adding the logarithms together, your answer is going to be the product of the two values. You're going to take the value x and the value y and multiply those two together. And I might say that's weird because that doesn't make any sense. Why wouldn't you just add the logarithms together? Because that's what it's telling you to do. Well, remember from back in chapter 7, if you saw a problem like this, you don't have to write this down, but if you saw a problem like this, at first you would have thought, oh, well, x squared times x to the 5th means that we have x to the 10th power because we're multiplying. But no, that's when we multiply and the bases are the same. Remember, we add the exponents, so 2 plus 5 is 7. And you've learned to remember that. You've learned to think that that's not strange. So we just need to learn that this isn't strange either, that when we have the log base b of x plus a log base b of y, that we would multiply those two values together. Because remember, these are dealing with, logarithms are exponents, so it makes sense then that the opposite of this would be true. If we're adding two logarithms, we would multiply those two values. So let's look at this first example. We have log base 4 of 2 plus log base 4 of 32. Well, from this theorem, we know that we would, since we have the same bases, we would multiply these two values together, 2 times 32. Well, 2 times 32 is 64. And log base 4 of 64, that can be simplified as well, because 4 to the 3rd power gives us 64. So that means my answer would be 3. So why don't you try this next one on your own? Log base 6 of 4 plus log base 6 of 54. So why don't you see if you can't simplify this down to a single, or write it as a single logarithm, and then evaluate that single logarithm like we just did and got 3 as our previous answer. So why don't you try that with this one. So pause the video and hit play when you're ready to check your answer. Okay, so let's check to see what you did. It'll be log base 6 of, remember, since we're adding these two logarithms together, we're going to take 4 times 54. Well, 4 times 54 is 216. And this, you could have used your calculator to try to figure out what exponent we'd apply to 6 to get 216. Well, your answer is going to be 3, just like the previous problem. Doesn't always work out to be 3, just so happen to be for these two problems. Now, it's really easy to know what we're doing when we're in the moment. Like right now, if I were to give you another example like this, you would know that you would multiply these two values together. But you want to make sure that you really understand this. You want to make sure that you do the assignment, make sure that you understand this and apply it, because otherwise, a few days down the road when you go to take a test, it's really easy to forget and go back into old habits of thinking that, oh, log of 6 of 4 plus log of 6 of 54, oh, I add those together, so it's a log of 58. Because that would be wrong. You want to make sure that you remember when you're adding two logarithms, you multiply the values together, the 4 and the 54, the 2 and the 32. So get the next theorem. Our next property here is called the logarithm of a quotient theorem. What this one states is that if you have the log base b of x minus log base b of y, you might already be guessing what you're going to do with these two, especially with the name of this theorem. Your answer is going to be the log base b of x divided by y, because quotient means to divide. And it also makes sense because if in the previous theorem, if when we added two logarithms with the same bases, we multiplied the values together, since subtraction is the opposite of addition, it would make sense that we would end up having to do the opposite here. So the opposite of multiplying is dividing. So we would divide the two values. But again, we need to make sure that our logarithms have the same bases. If they don't have the same base, these theorems aren't going to work. But these two bases are the same, log base 2 of 32 minus log base 2 of 2. So what we'd end up doing here is we're going to write this as a single logarithm, which would be 32 divided by 2, which gives us 16. Now I want to figure out what exponent would I apply to 2 to get 16. Please do not say 8. Okay, that's a common mistake. Again, we're trying to figure out exponents here. And if you're not sure what exponent you'd apply to 2 to get 16, you just have to do it the long way and say, well, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that took me 4 2's to get my answer. So my answer would be 4. 2 to the 4th power gives me 16, so my answer is 4. So why don't you guys try this one on your own. You're dealing with some bigger numbers, so chances are you'll have to use your calculator. So why don't you go ahead and pause the video and hit play when you're ready to check to see if you got the right answer. Okay, so let's see what you got here. You should have taken log base 4, write this as a single logarithm, so it's going to be 3072 divided by 3, because we're subtracting here, so we divide these two values. And now 3072 divided by 3 gives us 1024. And now you want to figure out what exponent would you apply to 4 to get 1024. Well, it turns out it would be 5. Okay, let's look at this last property. This is called the logarithm of a power theorem. What this theorem states is this. If you have a number in front of a logarithm, doesn't matter what the base is, that number is really the exponent for that value. Or we could look at it backwards. If we're given a situation like this, and if we're trying to simplify it, we could take that n and park it down in front of the logarithm. That's what this is saying. Or we could take, if, like I said earlier, if we have a situation like this that we need to simplify, it might make it easier if we take and write it as the exponent for the x, because that's how this exponent and this number relate to each other. They're the same. So let's look at this first example here. I want to take log base 3 of 9 cubed. Now, this question could be on a test where you'd have to do this without a calculator. Now, you might think, well, wait a minute, 9 cubed, that's, I don't know what that is. Well, if you did the work, you'd figure out that 9 cubed is 729, but then you'd have to take and figure out, well, what exponent would you apply to 3 to get 729? Well, that would take you a while. Well, this can be a really quick problem to solve if you know this theorem, the logarithm of a power theorem. all we're going to do is we're going to take this exponent, we're going to park it out in front. So it's going to be 3 times the log base 3 of 9. We're going to take this part here and we're going to simplify that. Well, log base 3 of 9, since 3 squared gives us 9, that simplifies to be 2. And 3 times 2 gives us 6. So that was a really easy problem to do without having to use your calculator. So why don't you try this next one again? I would not want to take 16 to the 5th power. That would take me 20 minutes just to do that. And then to try to figure out what exponent I'd apply to 2, I'd give up before I even got to that point. So why don't you guys apply this theorem and see if you can't figure this out without using your calculator. So pause the video and hit play when you're ready to check your answer. So here's what you should have done. You should have taken this 5 and parked it out in front. So it would be 5 times log base 2 of 16. Log base 2 of 16, that piece there, simplifies to be 4 because 2 to the 4th power is 16. And 5 times 4 gives you 20. So again, easy problem to do without a calculator when you know this theorem. Now let's see how much you remember from those previous properties when we go to solve for x in this equation. This is all one problem. Log of x equals 3 times a log of 2 plus log of 7 minus a log of 4. This one problem utilizes those last 3 properties we just talked about. Let's start with the last property we just talked about. Remember, we said that sometimes you'll have a number parked in front of the logarithm, and that number really represents the exponent for the x, or whatever the value is. So for this problem, that's what we see here. We see this 3 parked in front of this logarithm. That means that 3 is an exponent for the 2. So I'm going to rewrite this as log of x equals the log of 2 cubed plus the log of 7 minus the log of 4. Now 2 cubed, to save us some writing here, 2 cubed is the same as 8. Because 2 times 2 times 2 would give us 8. So now I want to write everything on the right side here, I want to write that as a single logarithm. Because right now I have 1, 2, 3 logarithms. I want to write this all as one logarithm. To do that, we're going to apply those third and fourth properties we talked about, dealing with adding and subtracting logarithms. Remember, if we're adding logarithms, we multiply the values together. So it would multiply 8 times 7 and get 56. And we would take then and divide by 4. And 56 divided by 4 would be 14. So here's what I have here. Now if you notice, log of x equals log of 14. We have the right side written as a single logarithm now. And my goal is to try to figure out what is my value for x. Well, in this case, I'm trying to figure out what value for x would make these two sides balanced. Well, that value would be 14. An easy way to look at it is to ignore those logs. When you get the two sides equal to each other, ignore those logs and solve for x. Well, we have it solved. X equals 14. So that would be your answer. Now I want you to try this next one. This next one has a piece in it that I think you'll be able to work around, but I want to challenge you to see if you can't figure out what to do if it was 2x here in the end. So what you're going to need to do is you're going to need to write this the whole right side, you want to write that as a single logarithm, and then see if you can't figure out what to do with that 2 in the end. So go ahead and work that out. So pause the video and hit play when you're ready to check your answer. Okay, let's see. Did you get the right answer? You should have gotten 25. Let's see how you would do that. First off, remember this 2, this is an exponent. Oops, this is an exponent for the 5. And 5 squared would be 25, so I'm just going to write it like that. And then what we would do is we would write the right side here as a single logarithm. So it's going to be 25 times 6, all divided by 3, because you're adding these two and minusing the other one. So we would multiply the 25 and 6 and divide by 3. 25 times 6 is 150, divided by 3 gives you 50. So we have this written as a single logarithm on the right, and we have a single logarithm on the left, so we could ignore those logarithms for right now. And you see that we have 2x equals 50. So if you divide by 2, that gives you your answer of 25. So if you got that, good job. That can be a tricky problem. Now, if you haven't done so already, why don't you print out your assignment from Moodle. But here are two of the problems in your assignment that we're going to look at, question number 2 and question number 8, that are slightly different from what we've seen in our notes. The process is still the same. So let's look at this first one, number 2 here. We have log base 5 of u equals 1/3 times the log base 5 is 64. So here we have a situation where there's a number in front of the logarithm. Well, that number represents an exponent, remember, for the 64. So I'm going to write this as log base 5 of u equals the log base 5 of 64 to the 1/3 power. And again, this goes back to chapter 7. I've had to say that a lot, though. These chapters overlap between 7 and 9 and 8 as well. But in that chapter, we talked about roots, and that's what this is. 1/3 power is a third root of 64. So we're trying to figure out what times itself 3 times gives you 64. Well, have you figured it out yet? It should be 4. 4 times 4 is 16. 16 times 4 is 64. So the cubed root of 64, this piece, gives you 4. So now we have this written as a single logarithm on the right, so we can ignore our logarithms. So we have our answer, u equals 4. Now number 8, let's skip down to number 8. Number 8 is also kind of tricky, because here we have a 4 in front of this log, so that's an exponent, but this time it's our exponent for our x. So I'm going to write this as log of x to the 4th power. I'm going to go ahead in the same step to save some space on your worksheet there. I'm going to write this as a single logarithm. So since we're subtracting, remember we're going to divide these two values. So 32 divided by 2, which gives you 16. So we have this written now as a single logarithm on the right, so I could ignore those logarithms. Now, this is kind of tricky. We're trying to figure out what to the 4th power would be 16. So if you're not sure what that is, you're going to raise each side to the 1/4 power. So now that leaves us with x on the left, and on the right, that's the 4th root of 16. In other words, what times itself 4 times will give you 16, which is 2. So that would be your answer for x. So there we got you started there in your assignments. Your assignment is to do that worksheet that's posted there on Moodle. So with that, good luck.